Okay, this is video 931, and the goal here is to be able to solve a system of inequalities by graphing. So the way that works is that we want to graph, we want to shade in all solutions that work for all the inequalities in the system. So really, the graph describes all the solutions by shading them in. We're coloring where the solutions are. So let's take a look at the steps to do this, because the good news is it's everything you've been doing. It's just you got to think a little bit harder at the end. Okay, so our first step is we have to have the equation written y equals mx plus b, because that's the only way to graph them. Now when we start to see nonlinear equations, so y equals ax squared, bx, and c, that's going to be a slightly different situation. But here we have a linear equation. We want to first start by writing it in slope-intercept form. Now we're going to graph the equations next. So that's easy. We can graph lines. What we want to remember is it's dotted lines if the symbol is less than or greater than. And remember, it's solid lines when the symbol is less than or equal to, or greater than or equal to. Remember, the symbols describe what solutions are part of the answer, and since the solid lines can be equal to the line, we want to include the line by making it solid. That means the line is included in the solution set. So we're going to graph the equations with the proper line, and then we find the solution region. Now this is the tricky part. This is the extra steps. We have to plug in points, and we're talking about multiple points from each region until you find the region that works. Remember, two things you have to remember to test all regions and all equations. I'm sorry, all inequalities, because they're not equations, they're inequalities. So let's see that in action. Let's look at an example. It's something you've been doing. You've been testing regions, but we have more regions to deal with, so that's where the more thinking comes in. So let's take a look at this first example. So our first step, like we talked about, was to get it in y equals mx plus b form. So I'm going to take the red equation, and I'm going to do that first step. I have 3x plus 4y equals negative 4. I'm going to move things around until I get y alone equal to something x plus b. So let's see, I'm going to take off 3 x's. I get 4 y's alone, negative 3x minus 4. And then I'm going to divide everything by 4, because I want 1 y. So step 1 is done for my first equation. I'm going to leave this as a fraction, negative 3 divided by 4x. So I didn't actually do the division that was described here. Okay, but I do need to divide the other 4 by 4. So negative 4 divided by 4 is negative 1. That's a nice division. I can get that nice number. So that's my red equation. I have successfully done step 1 for my red equation. Now I'm going to do it for the blue. So for the blue equation, I'm going to do the same exact thing. I'm going to solve for y. Get y alone so I can see what my slope is. Let's see, negative x on both sides so that my y's are alone. And then I'm going to divide everything by 2. So let's see, y equals 2 divided by 2, that's easy. That's going to be 1 plus. And then negative x divided by 2, remember that really means negative 1x. So it's going to be negative 1 half x. A little tricky there, but we got to work on those challenging fractions so that we can be better at this stuff. So I have my 2 equations in y equals mx plus b form. I'm ready for step 2. Step 2 is graph the equations, but we want to remember this key fact that we use dotted for those symbols and solid for the others. So let's see, my original symbols are matching with the dotted lines that we see over here. So I'm going to use dotted lines. That's important so I don't accidentally do it wrong and have to erase it. So let's see, I'm going to graph the red line with the dotted line. I'm going to use my slope and my intercept. So because it's negative 3/4 x minus 1, I'm going to start at negative 1. That's my y-intercept. And I'm going to go a slope of negative 3, 1, 2, 3 over 4. 1, 2, 3, 4. And there's my slope. And I'm going to do it again just to get another point. 2, 3, 1, 2, 3, 4. So I went down 3 and over 4. So I have my line. I could maybe work backwards to find some more. Going backwards 4, and then up 3. Continue my stair steps. Now I see the dotted line. I can shade it. Okay, so there's my first line. That's my first line for my system of inequalities. Now I'm going to draw the blue one. Once again, I'm going to use my slope and my intercept. My intercept is 1, so I'm going to start up at 1. And I have a slope of negative 1/2, so that means I'm going to go down 1 over 2. Down 1 over 2. Down 1 over 2. Keep going to make a nice straight line. The more points, the better line I'll have. Doing it again, going backwards again. So we go backwards 2, up 1 to keep with the stair steps. And once again, I connect it with a dotted line. So I have my 2 dotted lines to represent my solutions. And now I have to decide where to shade. So here's what I want you to notice. I want you to notice that there are 3 solutions. So we have a solution set that's in between here. That seems to be in the middle of these lines. Okay, we also have a solution set that seems to be below maybe these lines down here. We also have a potential group of solutions that's maybe above all the blue lines. What's really interesting though is because these lines go on forever in these directions, this line goes on forever, this line goes on forever. Eventually there's another region. It's hard to see what's over here. Okay, we're going to cross our fingers that maybe it's not that region, because that's going to be a hard region to test. But let's try and start by testing one of the regions. I always love to test 0, 0. So 0, 0 is right here, and it's in the region that's in the middle here, between those lines in the center of our graph. So I'm going to test 0, 0, and we always go back to our original equations. So we forget about all this great work that we did. We forget about all of this, and we focus just on our original equations. So I'm going to plug in 0, 0 and see if it's a solution. So 3 times 0 plus 4 times 0, is that greater than negative 4? Okay, so I plugged in 0, 0 into the red equation, into equation A. And I get 0 on the left, because all that becomes 0, which is why 0, 0 is so nice. And I get negative 4 on the right. And then I read the sentence, 0 greater than negative 4. And I think, oh, that's true. So far we're good. But it has to work in all equations. So it works in the red one, but we have to test if it works in the blue one as well. So now we test blue. I put 0, 0, and I test is this smaller than 2. And it looks like I get 0 less than 2. So once again, 0 less than 2. That's true. So that means that this region is, in fact, a solution, the solution set to my system. So that is what I shaded, the little region between those 2 lines. Now, we always want to be sure, especially on test day, to make sure no other regions work. Okay? We test other points, like if I wanted to test this point right here. This is the point 0, 4. Once again, it has a 0 in it, so it's going to be a little bit faster. and I'm going to plug it into my equations, A and B. So I'm going to plug in 0, 4 into both of my equations and see if it works. If it doesn't, then I can rule out that region. So 0, 4. And I get 16 greater than negative 4. And I see that's true. Remember, I got 16 because that became 0. I plugged in 0, 4, 0, 4. Over here, I get 8 less than 2. That is not true. So I know this is not a solution. So that black region that we would call maybe the region above, up here, is not a solution region because one point did not work. Okay, and I can continue testing. I got lucky testing 0, 0, and I found my solution region. With 2 lines, you'll only have one region. But when you have quadratics, we're going to have to test for multiple regions. And you'll see that in the next video or worksheet you do in class. So here's one to try on your own. Remember the steps that we talked about. How you got to get it y equals, how you have to graph the line, then you got to test your regions. So see if you can try this problem on your own. Stop the video here, do the problem, restart the video when you're ready to see the solution. So maybe you're at the same point that I am. I have now graphed the lines, they're dotted, and I see the different regions. The different regions are this region that I'm calling the green, because you see that one green point in there. There's the region down here, that's going to be purple. There's also the region that's kind of up here. It's going to be this light blue that you see that I crossed through right there, right in there. Okay. There's also this region down here that's going to be orange. And the problem is I have already tested the purple region, and I found it to be not true. I tested the green region, it was not true. And mind you, I've tested only the red equation. And it didn't work for the green point, the purple point, for the teal point, it did work. Red line, it worked. This worked for the red line right here. But when I did it for the blue line, it didn't work. So that tells me that that bluish point is now not the solution. So I'm at the point where I'm going to test the orange point. So I'm going to plug in the orange point into both equations. So I'm going to plug in the orange point, and I think the orange point is at -6, -9. It's way down there. So I'm going to plug in -6, -9 in for my red equation. So when I do that into the red equation, -9 for y, -6 for x, I'm going to see what I get. So I got -9 greater than -12 plus 1. And I see that this is going to be true. -9 is greater than -11. This is true. Finally, it works there. But remember, it has to work for both. So that's great. That's wonderful. But I have to test it for blue as well. So I'm going to test it for blue, the blue line, and I'm going to plug in, remember it was -9 for y and -6 for x. So remember, I'm using the equation that you see up here, and I'm plugging in the point. I'm testing if it works. And I see -9. It says -9 less than -8. Yes, it's true. So this is a true statement. So now I know to shade this little sliver down here. Okay? So that's my solution. It looks really small, but remember, if we were to make a bigger graph and had bigger graph paper, it would be really big. It's just small on our graph. So that's my solution set, and I'm done with this one. So sometimes you will try every point you can think of in every region. But remember, a region is always a boundary of lines. So if I were to draw all these in black, you would see a skinny little X. You see that little X? The 3 regions that I created was the purple region, that was over here, the green, the teal, and then the orange. And the orange happened to be my solution set. So remember to keep testing until it works for both equations. And you'll get better at testing and figure out which ones to test as you move on. So remember your 3 steps. Don't be scared by number 1. It actually is easier to graph than you think. Just think back to what the slope and the intercept are and ask your teacher if you don't remember. They're pretty easy to graph. Be sure to ask questions as you go along, or have your teacher check your answers as you move along. to make sure that you're doing it correctly.